Okay, so now we start with the lesson. What happens when an exponent is a fraction? Consider this as you answer the questions below. So you're going to use your calculator now to calculate the following three values: 9 to the 1/2, 49 to the 1/2, 100 to the 1/2, and look for a pattern and see if you can answer this question. I will give you a moment. Remember, in your calculator, you use the A to the B key. So if you were doing 9, then A to the B on the calculator, then 1 divided by 2, that would get you this number. Okay. All right, so hopefully you got 3. And then when you do the same thing with 49 to the 1/2, you should get 7. And with the last one, 100 to the 1/2, you should get 10. So when we look at this pattern here, how does 3 relate to 9? How does 7 relate to 49? How does 10 relate to 100? What effect does the 1/2 and the exponent have on the base? So I'm taking a look at your answers here. So let's go ahead. Does anybody know? You want to put it in the chat? So yes, it's a square root. So we're going to go ahead and type the 1/2 power gives us the square root of the number. That's hard to see in that color. Maybe I can change the color. That's better. All right, so we get the square root of the number using the 1/2 power. And just like on the side, we can check some of these. So, think about it like this: 9 to the 1/2 is equal to 3. The square root of 9 is equal to 3. We're getting the same thing, just with a different like a different format of the expression. All right. So now, oops. Okay, so Drake likes it. All right. Yeah. Okay. All right, here we go. Let's try this again. But this time, notice that we have 8 to the 1/3 instead of 1/2. So now we're changing our exponent from 1/2 to 1/3. So go ahead and punch these in your calculator and see what you get. Okay, so I'm seeing most people have answered now. So if you got 8 to the 1/3 is 2, negative 27 to the 1/3 is negative 3, and 125 to the 1/3 is 5. You are correct. And then I believe some people have answered the next question. So what is this doing? It's not a square root, it's a cube root. That's right. Thank you. So the cube root. So let's go ahead and type that in. The 1/3 power gives us the, whoa, I have it all in caps. Sorry, I didn't mean to shout. The 1/3 power gives us, and I can't spell, so that's pretty fun. The cube root. The cube root. So if we just do like a little note off to the side so you can see it sort of, 8 to the 1/3 equals 2 from above, but the cube root of 8 is also 2. And that's because 2 times 2 times 2, like 2 to the third power is 8. And this works for all of these. All right. I'm sorry for yelling at you with my all caps. Okay. All right, so let's go to the next. So there's a pattern emerging here. And so when we're looking at fraction exponents, a number to the 1/2 is equivalent to the square root. When you don't see a number in the square root, if there's no number showing in there, it's by default a 2. So this is the square root of a. A to the 1/3 is equivalent to the cube root of a with a 3 in the index. A to the 1/4 would be, I know this is hard to write sometimes with your stylus or your mouse, but you can kind of take up more space if you need to. The 4th root of a, and then a to the 1/5, that's the 5th root of a. And we continue that pattern for every fraction exponent. A to the 1/n is considered to be the nth root. And we put an n in the index. All right, so the nth root, that just means any number could go there. And we want to make sure that these numbers we put in are inside the little like V of the root symbol, not in front. And the reason why is because we don't want it to get confused with multiplication. This is not 4 times the square root of a. This is the 4th root of a. It's a very different thing, okay? All right, so we're going to learn how to use this. Okay, so for 6-37, understanding fractional roots, Danielle wants to understand why 9 to the 1/2 is the same as the square root of 9. Since exponents represent repeated multiplication, Danielle decided to write the number 9 as 3 times 3. She then reasoned that 9 to the 1/2 is asking for one of the two repeated factors with a product of 9. So see, we have 9 to the 1/2, which is equal to 3 times 3 to the 1/2. And then she just takes one of those two roots, and the answer is 3. All right, so we're going to follow this reasoning to break down each of these roots. And we know, like, now that we know that 16 to the 1/2 means the square root of 16, we know the answer is 4. But what I want to show you is a method that to break it down that will help us to simplify more complicated fraction exponent expressions, okay? So 16 to the 1/2, the 2 right there in the 1/2 tells me I need the square root or the 2 factors of 16. So I need 2 numbers to multiply to be 16, 2 matching numbers. So I'm going to write this as 4 times 4 to the 1/2. That's an equivalent expression. And then I want one of the 2 factors. That's the exponent is telling me to take one of those 2. So I'm going to take just this one, and that means that my square root is 4. So for 125, to follow the same reasoning, I have 125 to the 1/3, so I need 3 numbers, and that would be 5 times 5 times 5. That's 5 to the 3rd makes 125. So 3 numbers to the 1/3, and I want one of those 3 numbers. So that gives me an answer of 5. And finally, with 32, do you see how we have 32 to the 1/5? I need 5 numbers, matching numbers that multiply to be 32. And that would be 2s. So 2 times 2 times 2 times 2 times 2 makes 32. And then it tells me I want one of those 5 roots. So I'm going to take just one, and that gives me an answer of 2. So this seems like extra a little bit, but when we complicate our exponent more, this becomes kind of a nice tool of how to break it down. We want to get to a place where we could do these kinds of calculations without a calculator. So we want to make sure that we understand them, how to change them in, like how to break them down, how to maybe think about them as with radical notation or exponent notation. We want to be fluent with how they work. All right, so I'm going to clear and go to the next slide. Okay, so for this, now can you see how our exponents are a little bit weirder? Our exponents are a little bit more complicated than just 1 over a number. So, but we're going to follow that same method. So I'm going to go ahead and notice how the denominator in the exponent, 27 to the 2/3, the denominator is a 3. So that tells me I want cube roots. So 27 is 3 times 3 times 3. And now, instead of 1 of the cube roots, I want 2 of the 3 cube roots. So I'm going to take 2 of these, and 3 times 3 would give me 9. So 27 to the 2/3 is 9. And if you want to check on your calculator by punching that in, that's a nice way to verify that we did this right. Okay, so we're going to try this with the next one. So why don't you give it a try, and I'll take a look at your slide and see how you're doing on this. And then we'll check our answer in a moment. So follow the process. Notice how there's a 5 here. So we want to break down the 32 into 5 numbers, and we want 3 of them. All right, so now let's go ahead and get this problem done. So if you broke this down, 32 into 2 times 2 times 2 times 2 times 2, that was a good first move to the 3/5. And then we want 3 of the 5 roots. So I'm going to take 1, 2, 3 of those 2's. And in the end, we get 8. Okay. All right, and then finally, the last one, which is sort of weird because it's a little extra, we have 25 to the 3/2. So the 2 in the denominator of the fraction tells me to break it down into square root, like 2 numbers times each other, like a number times itself twice. That makes 25. And then for this one, I want 3 of those. I want 3 of those roots. I have 1, 2, I need another one. So what I'm going to do is actually, I need an extra 5. So I'm going to multiply by the square root of 25 3 times. So that's sort of a good way to think about this. What I just did was I multiplied the square root of 5 3 times. The square root of 5 3 times. So it's like this, or sorry, the square root of 25 3 times. So the square root of 25 and then 3 times. So I cubed it. Look at this. This means the square root of 25 3 times. So I want to point this out for our next slide. This is something we're going to focus in on. The denominator of the exponent tells us the root that we're going to take. The numerator of the exponent, the number on top, that 3 there, tells us the power, how many of them we want. So we're going to be making this connection so that if you did want to like maybe use a radical notation instead, you have another option. All right. So here we go. So this is using radicals to calculate fractional exponents. This is another method for calculating these roots where you can convert them to radical form first. So oftentimes radicals get a little jumbled, but we also often have a more like instinctual understanding of a square root or a cube root in this format because we're more used to it. It's more familiar. So when I have a problem in a fraction exponent form, I can always switch it to radical form. Like I'm allowed to do that. That's no problem. They're equivalent. So if I have a number like any number to a fraction exponent, You just have to keep in mind that the denominator of the exponents fraction is the root. So that determines our square, like what kind of root. Is it a square root, a cube root, a fourth root, a fifth root, etc.? That's the nth root. And then the power is the number on the top, and that tells us how many we want to multiply. So like sometimes it's a 1 and we just need one of them. Sometimes it's a 2 and we want 2 of them, etc. So in this example, 125 to the 2/3, you can see that the root is a 3 and the power is a 2. So I'm going to just make a note. Root, 3, power 2. So when we look at it in as it's worked out, you can see how the root tells us that we need a cube root. It's a 3. And the power tells us we need 2 of them. So when we take the cube root inside of 125, we get 5. And then we square it because we want 2 of them, 5 times 5. And that gives us our answer, 25. So we're going to follow this similar process for these next two. So you could do this with the like repeated multiplication method, which we were doing on the previous slide, or you can use this, turn it into a radical method. So for the first one here, 32 to the 2/5, I'm going to identify my root and my power first so that I organize it correctly. So I'm going to just type down below. The denominator is the root, the numerator is the power. So I have a root of 5, and I have a power of 2. So I want to take the 5th root of 32, and then I want 2 of them. I'm going to square it. So when I write this out, it should look something like this. Oops.
I know that like I have to be
the 5th root of 32,
where we are now,
and then squared. And the 5th root of 32 is 2. So I calculate that root inside. So now I need 2 squared. And in the end, that gives me 2 times 2, which is 4. So this is an alternate method for calculating fractional exponent expressions. So I'd like you to try this next one. Identify the root, identify the power, and see if you can convert it to radical notation. That means with the root symbol, and calculate it this way, again, without a calculator. All right, so we're going to go ahead and check. So let me do some typing here. So remember, the bottom number in the exponent fraction is the root. So let's identify, we have root, root is 2. And then the power is 3. So a root of 2 means the square root. So when I write this out, what I'm doing is, let's just divide this up. Okay, what I'm doing is I'm taking the square root of 9, right? That's what that 2 tells us to do. So we take the square root of 9, and then I want 3 of them. I'm going to raise it to the 3rd power. Square root of 9 inside, 3rd power. That's what my root 2 power 3 tells us to do. And then when I calculate this root in there, root 9 is 3, and I'm still raising it to the 3rd power. And that gets me 27. 3 times 3 times 3. So if you got 27, awesome. Okay. So go ahead and get that written down, and then I'm going to switch slides. And here we go. Okay, so now this is a really it's just sort of like we're going to do exercises on this slide. We're not actually going to try to get a final number necessarily on this slide. What we're trying to do is practice changing the format of each expression. So some of them have radicals, and then we'll want to change them to fractional exponents. Some of them have fractional exponents, and we'll want to change them to radical notation. So we want to be able to switch back and forth and apply exponent rules when it's appropriate to rewrite these expressions. Sometimes the goal is to simplify them completely. Sometimes the goal is just to change the format or the notation being used. So we're not trying to get answers on these right now. This is not about a calculator. This is about practicing converting from one form to another. So looking at the instructions here, it says, now that you have many tools to rewrite expressions with exponents, use these tools together to rewrite each of the expressions below in two different ways. So I want you to notice in the example, we have the square root of 2 to the 5th, and then it's rewritten, changed from radical form to exponent form. And this is the first new equivalent expression to that original expression. And then it looks like what was used to go to the next expression was a power to a power exponent rule, where the exponents multiply. When we raise a power to another power, the exponents multiply. 5 times 1/2 is 5/2. So this is a new representation that is also equivalent. Each of these expressions, what we want to do is write 2 equivalent expressions. We don't need to get an answer per se. Not like the goal is not to just get the number without any fraction, exponent, or radical. The goal is to change their form and get practice doing that. Okay. So in part A, what I see is a radical notation inside with root 3. So my first instinct is, well, could I rewrite it where it doesn't have a root radical notation, where it's with exponents instead? And so maybe something that can be helpful is to have sort of a list of exponent properties that help us. So like, we know that a number, we know that the nth root of a number is equivalent to the number to the 1 over n. And in general, we also know that, we also know that when we have, let's do the exponent first. When we have a number to the m over n, this can be converted to a root like this. Remember, this is what we used on the last problems, like trying to, oh my gosh, that looks really sloppy. Let me just fix that one more time. There you go. Let's try this again. The nth root of a to the m. So those are equivalent. And then there's one more property that will probably come up because it came up here in the example. When we have a number to a power and we raise it to another power, then the 2 exponents multiply. And this was something that we worked with last class in our exponent properties day 1 lesson for 6.1.4. So these properties up here can help sort of guide our work. So in part A, my suggestion is to try to rewrite this with using this property up here. Change the square root to a number to the 1/2 inside the parentheses. We're just practicing rewriting the formats. So I'd like you to just go ahead and give them a try. I can do some with you after a little while, but there may be more than one way to do them, and I don't want to like force you into doing it just one
Isn't this
specific
when we had
way.
months and months, we're all feeling a little bit overloaded with our work and with.
So again, what we're trying to do is just rewrite the expression, like in part A, for example, rewrite the expression so that it means the same thing, but it's in a different form. So we know that root 3, the square root, is equivalent to a number to the 1/2. So what I'm going to do is I'm going to leave the exponent the same, the parentheses the same, but I'm going to change the root 3 to be 3 to the 1/2. And now what I have is a new expression that is equivalent to the original one. It's just written in a different format. And then we want to try to, it's like a transformer. So we transformed it. It's still the same thing. It's still the same amount of stuff. It still represents the same value. It's just in a different format. So now what I'm going to do is I'm going to rewrite it one more time. And in this case, since I have exponents raised to another exponent, I'm going to use this power of a power property and multiply my exponents. This is like a nice way to take it a step further. So now this will be equal to, these are all equal to each other, 3 and then 1/2 times 4. 1/2 times 4, I'll just do off the side, 1/2 times 4 is 4/2, which is 2. So I'm going to go ahead and write my exponent as a 2. And this is now my second form of the same expression. If you wrote it as 4/2 in the exponent, that would be valid. That's fine. If you wrote it as 9, that would be valid. But we don't have to go further because it's just wanting us to rewrite. It's just wanting us to rewrite each expression in 2 ways. So I'm going to give you a little time now to try to rewrite a few more. We don't have to do all 6, but I mean, I'll go through them all, but I want you to like grapple with a couple more. So try to do B, try to do C, and if you have time, go on to the later ones, and then we'll go through more quickly as a class. So in part B, I see all fraction exponents. So this makes me think I want to put it back into radical notation. So maybe use like this property up here with the a to the m over n. So I see that the denominator is a 2. So that tells me my root is 2 and that my power is 7. So I'm going to do the square root of 9. You don't have to write a 2 in the index, but you can. And then, because the default is a 2, and then I'm going to raise that to a power of 7, the square root of 9 to the power of 7. So this is my first equivalent expression. Oh my gosh, I can't get that 7 in there. Okay, there's my first equivalent expression. The default for a root is 2. It's because we don't really take the first root. The first root is itself. So if we do a square root, that's like the most common root. We just, when you see a square root symbol, this is the square root. And that's just like, it just is what it is by definition. That's the second root. And then if we up the root from there, we put in the new number, like the cube root. So now I'm going to go ahead and convert this one more time. I actually know that the square root of 9 is 3, so I could totally rewrite this as 3 to the 7th. And that is another representation of this expression. So there's 2. Thanks for that. Oops, I forgot to record. All right, so here are our, sort of answers for the rest of them if you want to check your work. If you only did a few, that's fine. I just want you to have some practice with this, okay? If you need to take a screenshot, fine, or I'll have this is in the video. So you can go ahead and like look it up later. All right, I know that this is a little fast and that you won't have time to write it down. Please don't worry about writing it all down, okay? I'm gonna clear these and go to the last slide so that we finish up the lesson. So this is the very last one before closure. This slide is a matching slide, so we're trying to find equivalent expressions between the lettered expressions and the numbered expressions. So, so I'm going to go ahead and get my line tool here. So the square root of x to the third, I would do something like, oh, let's change it into exponent form. So this is x to the third to the 1/2, because that's the square root. And then multiply exponents 3/2. Oh, x to the 3/2. I think that's down right here, number 3. So A goes with 3. See that? We can just do this piece by piece. Just try to manipulate your expressions until you find one that matches. So x to the second over x to the fifth. When we subtract exponents, we get x to the 2 minus 5, which is -3. And that tells me that 8 goes with B. No, it's sort of hidden down there. The cube root of x to the fifth. So just keep on working through them. Like, how do we change their format? That's x to the 1/3 to the fifth, which is x to the 5/3. Oh, look at that. That's number 7. Okay. 1 over x squared. That's x to the -2. That's one I can do in my head, x to the -2, using my negative properties. X squared, cube root of x squared. So I can do this. Let's see, this is x squared to the 1/3. That gives me x to the 2/3, which looks like E goes with 6. Oh, this is my favorite one. 1, anything to the 0, boom. Here I'm going to add my exponents, and this gives me x to the first, which is just plain old x. And then finally multiply these exponents, x to the 1/2 to the second. That's x to the, or 1/4 to the second, that's x to the 2/4, which is x to the 1/2, which is, I already used that color, the square root. So there they are, all of the lines. Yay. All right. So this is it for today. The next slide is your closure slide. So you can go back and be able to describe the relationship between a fraction exponent and a radical notation, the square roots and cube roots and how they connect. And then the homework is on the last slide.